Hey all, a very good evening to all of you. My name is Rahul KANYAL and I'm going to take you through this startup series, and we are going to talk about forming part 1. Alright, and if you were there in the previous class that I took in the afternoon, that is a 2 p.m. class, alright, we have had an introduction of it. Even if you are not there, we will talk about what forming is today. Okay, we are just going to explore the basics of forming here, guys. Alright, basics of forming. And if you have not subscribed to this channel, please go ahead and press that subscribe button. Believe me that you're going to like that subscription. Now this is about me. I'm a senior faculty for mechanical, GATE and ESE at Gradeup. Alright, and yes, concept on fingertips is another series that I offer, and that is offered at 2 p.m. daily, Mondays to Friday, and I suggest that you also come there. All right, it's really a value adding program that we have added. All right, a very good afternoon, Karu Mandi. Yes, Shamila, a very good evening. Not good afternoon, good evening. Sanjeev Kumar, how are you? I hope that you are really doing good. Okay, now we have a Target Gate 2021 class. Batch 2 is starting, and you can always start a free trial with us. And these are the quick specifications of Target Gate 2021. All right, now yes, now let's coming back to the topic. Okay, we are going to talk about forming. Okay, now what is forming? As you can see here, all right, this is an iron job that has been given a C shape, right? Now this is nothing but a C-shaped job, right? Isn't it? Now it has been given a form here. So forming is nothing but a process of giving a form, right? So we just say that a process of giving a form here. Okay, now those people who were there in afternoon at 2 p.m, yes, I'm going to repeat a bit of the concept here, but yes, we have more questions here. Right, guys? Yeah, Shubham, how are you doing? Gajendra, very good evening. Gajendra, okay. Gangadhar, hi. Is that good? Okay, fine. So forming is a process of giving a form through a permanent deformation. Okay, through a permanent deformation. All right. This is what we say. All right, to a permanent deformation. All right. So some of the topics we are going to repeat it, but yes, we are going to do some more questions in here. All right. Okay. Yes, just one. How are you doing? Is that good? Now let's talk about recrystallization temperature. Okay. Recrystallization temperature. Okay, I'm going to just mention it using RCT. All right, guys. Now this is a temperature at which what? The temperature at which we all know, right? I'm going to just quickly go through these concepts. So very good evening, Sachin, Brijesh. Yes, how are you doing? At which new stress-free grains are formed, right? That's called a recrystallization temperature, right? At which new stress-free grains are formed, all right? And RCT is generally given something like this. Okay, so it has a range of melting point upon 3 to melting point upon 2. Okay, so where, just note this, guys. All right, this is going to be really very important to you. MP equals to melting point. Okay, this is nothing but melting point. Very good evening, Sachin, Brijesh. Yes, Jaswant, how are you doing? Okay, please mention this. Okay, please note this. So recrystallization temperature is generally given something like this, okay? So melting point upon 3, 2, okay? This is the range of recrystallization temperature. Don't say that this is minus. This is not minus here, okay? So this is range. Is that good? Yes, it is. Ajit, yes, it is very much applicable. Is that good? Hello? Is it good? Now let's say that, okay, melting point of steel, let's say that melting point of steel is nothing but 1400 degrees Celsius, okay. Now can you please tell me the range of RCT? So range of recrystallization temperature is what? Is nothing but, 1400 upon 3 degrees Celsius to 1400 degrees Celsius upon 2, right? This is according to this formula over here, isn't it? Yes. So can you please just do this, all right? Can you please just take a note on this, all right? Is it good? So you can calculate this, okay? So that's what it is. So range of RCT is nothing but 1400 degrees upon 3 minus. This is nothing but a theoretical range that is given to us, okay? This is nothing but theoretical RCT that is given to us, okay? That is generally coming in this range, okay? Melting point upon 3 to melting point upon 2. Is it good? Now what happens is, now there's no, we don't have nodes, Arvind, we don't have nodes. Yeah, Shamila, okay, so you got that value, right? So now let's talk about hot forming versus cold forming, okay? Yeah, Banot, you're right, okay? Yes, you got it correctly. So that should be the theoretical value of recrystallization temperature, right? Now it depends on you, okay? It depends on obviously us, which temperature do we need, which temperature is actually practical for us to follow, okay? Depending upon various parameters, depending upon process capability and all those things, okay? Now hot forming is done as greater than recrystallization temperature, okay, is done at greater than recrystallization temperature, hot forming. Is that good? Now cold forming is done at ambient temperature. At ambient temperature. Ambient temperature means whatever temperature that you're working. For example, right now, if the room temperature is, let's say, 23 degrees Celsius, so that becomes ambient temperature for me. Is it good? Now hot forming, second point, hot forming is which one of these do you think is going to be, okay, let's see, okay, let's go back, okay. Now this is here, this is, what is this? This is nothing but a hot forming process, right? Okay, even before this, let me show you a video, okay. Okay, we'll come back to that, the discussion of that, we'll do that. Okay, now we have a video, something like that, and it has shown, how these hot forming takes place, okay, in industries. So just have a look, right? Just have a look. I'm going to play this for 1 or 2 minutes. Let's see how it goes, all right? Now you can see a shaft over here, and it is hot formed. Anirudh, yes. Yeah, Srinu, you're right. Good evening, okay? Now this all is a hot forming process, okay? Yes, because the process or the workpiece is really hot here, right? So we are just looking at hot forming process. Yes, I hope that you are getting the intuition here. I hope that you guys are able to visualize what hot forming is, right? Now you'll never forget it, isn't it? Now see, that's a big, very big shaft. All right, now let's get into the next video, right? Now I'm going to tell you what is cold forming, all right? So let's say that, okay, so quickly I'm going to go through it. Okay, now let's say that this is a sheet metal over here, okay? Now this is a sheet metal and we are doing a roll forming here. And it's converting into a V-shaped sheet. Now, is this hot or cold? Now, is this process, is it hot or cold? Just tell me, guys. Hello. So the question is it hot or is it cold, right? So what do you think about it? Come on, guys, 28 people out there. So whatever I had shown to you, right? So again I'm going to just go back and make you understand this. Okay, now this is not working. Yeah, Rishabh, our team will certainly help you, okay? Our team is certainly going to help you, all right? So let's say that, okay, now again, I am going to just talk about this, all right? So this is coming out of as a V-shaped sheet, all right? So here, is it hot or cold? Certainly this is cold, right? We are not seeing any hot objects here, right? Those heated yellow objects. So obviously this is nothing but cold forming, all right? Is that good? So that was cold. So I think that you known what is the difference between hot forming generally, okay, and a cold forming. So going back, I'm going to again tell you what is the meaning of hot forming and cold. So obviously it's done at greater than RCT, so that stands for recrystallization temperature, and cold forming is done at ambient temperature. Yes, you're right. Karu, Sampul, yes, Shamila, Adal, yes, you're right. Okay, is it good? So that's what we talk about. All right, now hot forming. Okay, now when we make hot forming, the surface finish is not good, okay, in hot forming, as you can see. So surface finish is not good, all right? Is that good? Now the second one, surface finish is good. Surface finish is good. Is that good? Yes. Is it good? Yeah. So that's what we talk about here. Okay. Now the ease of operation here. So hot forming is a bit tough to do. Okay. A bit tough to do. Okay. And the cold forming is a bit easier to do. Okay. Is it good? So just take into these things, okay, three of the common differences that we can see in hot forming and as in cold forming, all right? All right, is it good? So that's nothing but greater than RCT. RCT stands for recrystallization temperature. That is the temperature at which new stress-free grains are formed, okay? Everything is from the beginning, okay? Yes, the material feels really good and fresh after that. So that's all right? Now this is the grain orientation of a cast part, okay? This one is after casting, all right? And this one is after machining. Okay, and this one is after forging. Okay, forging is a type of forming. Okay, so this is after forging. So if you talk about strength requirement here, okay, so if we talk about strength, then certainly let me tell you that forging has more strength than machining, that has more strength than casting. All right, casting has the least strength. Are you getting this? So please remember this thing, that the forging or the forming part, because of this grain orientation, okay, because of this favorable grain orientation like that, all right, the strength of forging is going to be the maximum here. Okay, so Anirudh, RCT is nothing but, recrystallization temperature above which stress-free grains are formed. Okay, so that's what it is, recrystallization temperature. Okay, there's a temperature in which if you heat a material, new stress-free grains are formed. That's what it is. Anirudh, okay, is that good? Because those molecules, those grains keep on getting the strength, not the strength, the energy. Okay, and if they get the energy, then certainly, you know what, they let loose of their previous orientation, and after that new stress-free grains are formed. So that's what it is. All right, Anirudh, I think that I replied to you. Now please remember this, forging is greater than machining, that is greater than casting. All right, because of these orientations like this. Okay, this one is a very favorable natural orientation. This is a very natural orientation, this one. Okay, if you can see, the fibers are oriented like that. Yes, they are oriented naturally, while here the fibers are along the direction of machining like this. Okay, and here it's a random orientation. That's why casting is not very strong, right? Okay, now I think that we have seen the hot forging video, hot forming video. We have also seen the cold forming video. All right, now let's jump to the questions, guys. Okay, there comes some interesting part. All right, now the first question is that which of the following can be hot worked at room temperature? Okay, now the hint here, let me give you a hint. Okay, just find, okay, because there's a relationship at, okay, fine. So recrystallization temperature is nothing but, melting point upon 3, 2. This is not minus. Okay, 2 melting point upon 2. Okay, the hint is that find out the option with least melting point, right? Find out the option with least melting point. So which of the options do you think is the least melting point, right? So that is the hint here, because RCT is nothing but melting point upon 3 minus melting point upon 2, isn't it? So this should be the room temperature, right? This should come out to be the room temperature. Yeah, Sanjeev, Shamila, Sanjeev, Jashwant, good. Trujan, every one of you are saying C. Yes, good. Well done, guys. All right, good. This is what I need. Okay, this is my job to make yourself intuitive here. Yeah, Sanjeev, good. So the option here is tin. All right, lead and tin, if you remember, okay, have very less melting points here. Okay, are you getting this? So it's almost around sorry for that. It's almost around 240 degrees Celsius. Okay, tin. Okay, yes, so Lalit Kishore, yes, you're right. All right, so what we said, find out the of the option with least melting point. So least melting point is 10, all right. So that RCT, recrystallization temperature, becomes melting point upon 3 to melting point upon 2, right? So that's why. Is it good? So least melting point. Now, given that A and B are hot formed and cold formed respectively, which of the following is true? So can you just think about it, okay? So A is what? A is hot formed, okay? And B is cold formed, okay? Now, if you just remember this, okay, we are talking about heat generated by machining A. Okay, heat generated depends upon what? So, heat generate depends upon friction, right? This is the hint to you, okay? So, heat is directly proportional to friction, and friction is directly proportional to what? Surface finish, right? Now this is a big hint for you, right? Now I said that heat is directly proportional to friction, which is directly proportional to surface finish, right? or alternatively, let me put it something like this, okay? So this is nothing but coefficient of friction, okay? So friction is directly proportional to coefficient of friction. So which one of these, okay, will have more coefficient of friction? Because we have talked about it here, right? We talked about surface finish, isn't it? We talked about, where did we talk about? Okay, lots of pages out there, right? So here we talked about surface finish is not good for hot forming. So coefficient of friction should be what? So I'm going to just write coefficient of friction. Should it be higher or should it be lesser, right? So mu should be higher, and fourth, mu should be lesser, right? Coefficient of friction, because surface finish is not good, so mu should be higher here, right? So which option do you think we have? Yes, now you're getting this. Are you getting this, guys? Hello? So mu for A should be higher, right? So mu is higher for hot form material and mu is lesser for cold form material, right? So heat generated by machining A, so it should be lesser, right? It must be greater than B. So this is how it should be, right? So A should be the option. Now how many of you got it correctly? Type in I. If you got it correctly and understood it, just type in I. And is there anyone who wants me to repeat it? Okay, so just tell this. So Sri Hari says it's I. Good, Sri Hari. So Jashwant, A, yes, good. So there can always be a machining after a forming operation, okay? Remember that. There can always be a machining operation after forming, okay? Yeah, Jashwant, you're right. So we have A here. So Adil, Karu, Sanjeev. I want more names out there, guys. Come on. I want more eyes out there. Yes? Just 3 people, Chaitanya, Joe, Srihari. So what I said is, okay, Srihari wants me to repeat it, okay. So I said that hot formed has, the surface finish is bad, okay. So coefficient of friction here should be high, right? The coefficient of friction should be high, isn't, because surface finish is bad, right? So surface finish is bad in case of hot forming, okay, and surface finish is good in case of cold forming, right? Srihari, I'm talking to you. Okay, now if surface finish is bad, certainly more friction force is going to be applied here, right? Isn't it? Anirudh, the surface finish is bad in case of hot form, so mu is going to be higher, right? If mu is going to be higher, then heat is also going to be higher, right? So that is what the concept here. Okay, so here mu is going to be lesser because surface finish is going to be good, so that's why. Are you getting this? So A is hot form, so mu is higher. So mu high means that what? Friction force is higher, right? So I can write that heat of A is greater than heat of, is it clear, Anirudh? Srihari, yes, yes, okay, good guys. Next question. Okay, now given that A and B are hot formed and cold formed respectively, which one of the following is true? Productivity in producing A is greater than B, right? What do you mean by productivity? First, let's talk about this, okay? So, productivity is nothing but ease of production, right? So, productivity means that ease of production, isn't it? So, productivity, so ease of production, is it going to be more in hot worked, hot formed, or cold formed? Which one? Ease of production, is it going to be more in hot formed or in cold form, right? I had shown you a video, isn't it? Again, I can show you that video, right? So you can look at this video, okay? So this one is a cold forming process, okay? This is just this. Okay, so where are we? Fine, this one. Right? So this is nothing but cold forming process, right? So this is cold forming. Now let me again show you the video so that you are convinced. Okay, now this is hot forming. Okay, so yeah, now all of this is hot forming. So what do you think is easier to produce? Is it hot forming or is it cold forming, right? All of these processes, isn't it? So it's very clear to me, right, that hot forming is a bit difficult here, isn't it? This thing all, managing this job, because it's really very hot, and firstly, heating this job of a recrystallization temperature, that is a tough thing, right? So what is the meaning of that? So hot forming, ease of production is better in cold forming, okay? It's not good in hot forming. So are you getting this? I have shown you a video, guys, all right? Just once, yes? So cold forming will have more ease of production, right? And hot forming will have lesser ease of production, isn't it? It's very difficult, hot forming, really very difficult. It's also very dangerous, right? So what do you think? So productivity in producing A. So A is hot formed. So A is hot formed here and B is cold formed. So what do you think is the option? Come on now, please tell me. I have told you the theory. So productivity in producing B is greater than A, right? So I think I will also go with, come on guys, you have 20 seconds. So I have told that ease of production in cold forming is more because we don't have to heat it, isn't it? We just have to put in raw material, and from the other end the finished product comes up, right? So it's much easier. So which option? Yes, B is the option, right? So productivity in producing B is greater than A. Yes, so that's what it is. So productivity is always done in terms of time, Ajit, yes? Ajit, so productive, how do you measure productivity? It's in time, right? So that's why it has to be B. Yes, are you getting this, guys? Hello? Are you getting this? Yes, Sanjeev. Just one. Yes, Sanjeev, Santosh. Sanjeev again. Bhaskar. Yes, Chaitanya. Good, guys. Good. So you're getting this. This is really satisfactory for me. Just one. Yes, yes, that you're right, Ajit. Okay, forces will be lesser in case of hot forming. But again, if you go back to inertia, high strength material can only be hot formed, if you realize this, Ajit. Okay, so is it good? So fine. Now the next question. Okay, now which of the following is correct? Now again, even before this, let's talk about another thing. Okay, let's talk about this. Now let's say that a component is already cold formed. Okay, a component is already cold formed. Okay, so what it means is that cold form means that it has residual stresses. All right, so it has residual stresses. Now just one feedback, guys. All right, can you understand my accent and my language? Just on a lighter note. So I'm going to again repeat it. Can you understand what I say here? Can you understand my language, my accent? Okay. And let's say that B is hot formed. Okay. So it doesn't have residual stresses. Okay. No residual stresses, right? Now, because A is cold form, it has more residual stresses, so it also has strains, right? Isn't it? Now, because of strains, it has higher energy, isn't it? It has higher energy, yes, than hot worked or hot form, right? So hot form, am I okay? So residual stresses, strains. Okay, so let me get rid of this. Okay, Anirudh, I'm trying. All right, it's a bit difficult writing in this. Okay, okay, Chaitanya, thank you very much, Anirudh. Okay, fine, just one. Okay, residual stresses. Okay, fine. So I'm coming back to you. Okay, Mahesh, I'm coming back to you. So strains will lead to more energy. All right, more energy than B or hot form, because they don't have any stresses, right? Hot form. Is it good? So Mahesh, let me come back to you. Okay, residual stresses means that, okay, fine. So let's say that, okay, let's say that I have this bottle. Okay, I have this bottle. All right, now it has been formed here, right? Hello, who was asking this? Mahesh. Is it, this is formed here, right? This is not welded, just a simple forming operation here is done, and they also have made some threading over here. All right, so in making this, because it has been permanently deformed, now this bottle is deformed, so it already has stresses. So that is what is the meaning of residual stress. So again I'm going to repeat it, Mahesh, because this bottle has been formed, okay, and there is a permanent deformation in this. Do you understand permanent deformation? There's a permanent strains in this. Okay, so strains cause stresses. Okay, so that is nothing but residual. Residual means from the very beginning. The stresses that you have from the very beginning, those are called residual stresses. Is it clear to you? Is it clear to you? Okay. Now, recrystallization temperature of cold worked, yeah, Mahesh, always a privilege, okay? It should be lesser than recrystallization temperature of hot. Why? Because it already has more energy, right? It already has more energy. It has more energy than this hot. Hot working has less energy, right? So that's why recrystallization temperature of cold worked product or any material should be lesser than RCT, recrystallization temperature of hot worked material. Is that good? Yep, guys. Could you understand this? Because it already has more energy, right? Recrystallization temperature of a cold work component, it already has more. For example, this is a cold work component, right? Isn't it? This is a cold form component, so it already has stresses. Are you getting that? If you're not getting this, just keep this in mind, okay? So RCT of cold is lesser than RCT of hot, not hot. Okay. Sometimes it happens, right? Funny things happen. Is it good? Just type in I if you could understand that, and so that we can move ahead, okay? Now let's take this. Now, which is the correct option? Which of the following is correct? Come on, let's do this. So we are talking about recrystallization temperature of what? Hot versus cold, right? So which is correct? So cold versus recrystallization temperature of hot. Yeah, Mahesh, Sanjeev, Anirudh, good. So कौन सा option सही है? Which option is correct over here, right? So just we have talked about it, isn't it? We just had a discussion about this. Which option will you lock? Okay, so Chaitanya, Jaswant, Sumit, Sanjeev, Alok, and yes, Safu, right? Okay, I cannot pronunciate. Sorry for that. Bhaskar, Mahesh, Sharmila, Samarth. Yes, it has to be B. Okay, so of cold work components are lesser than those of hot work components. Okay. Yes, Srinu, that is going to be permanent. That's what we are saying, that it's a residual stresses from the beginning. Okay, it's going to be permanent. Yes, Srinu, it is always going to be permanent because there's a permanent deformation here, right? Okay, guys, so every one of you got it correctly. Good, congratulations. Now, now, if the magnitude of cold working in A is greater than B, which of the following is correct? So what we are saying is that cold working in A is greater than cold working in B. Working is nothing but, cold forming. Okay, don't get confused. Just remove this if you are getting confused. Okay, if the magnitude of cold forming in A is greater than B, so A can be easily hot worked than B. And B can be easily hot worked than A. Now we are again talking about here, easily hot worked. We are talking about here, what about we are talking about? We are talking about productivity. Right? We are talking about productivity. Is the productivity of A greater than B? Or what? That's what we are talking about here, right? And productivity depends upon what? Here we talked about it, right, guys? We talked about here productivity of cold form is always greater than, so productivity of cold form is greater than B, right? So here also, going by the same concept, A can be easily hot worked than B, isn't it? Because A has more energy, right? Cold of A, okay, let me write it again. So productivity you need to find, all right? So what it means here is energy of A is greater than energy of B. So productivity of A is also greater than productivity of B, right? Energy of A is greater than energy of B, so that's why A can be easily hot worked than B, right? Because it already has energy, isn't it? Yes. Two people are there, right? Two students are there, A and B, okay? Okay, so let me write it over here. Let's say that two students are there, A and B. The energy of A is high, okay? So let me write it. Energy of A is high and B is less. So which one of them can be easily motivated, A or B? Let's say that they both are preparing for GATE, let's say. Is that good? They both are preparing for GATE. The energy of A is high and B is less. Now, which one of them can easily work? Cold working increases. Yes, Ajit, yes, it does. It increases the strength. Dharmesh, okay, let's take this question, okay, till the end. All right. So energy, which one of these do you think that, they can easily work, A or B? A has high energy, B has less energy. So I think that, what? A is going to easily work, right? A is always going to easily work for GATE, right? Because it already has high energy. So here also same thing is happening, right? Energy of A is greater than energy of B because cold working A is more than cold working of B, right? So same concept, guys, okay? Same concept. So the answer is A, okay? For the next question that I tried asking you, all right? So that's nothing but it's easily working for GATE. So A will work. So similar concept here. So A can be easily hot worked, all right? More strength, more the strength will be more. Ajit, what is the statement? What is the statement? So A is cold worked, all right? More the strength will be more. What is the meaning of that? I could not understand it. Okay, Ajit, if you can give me a better analysis, okay? Now just tell me, all right, what is the area under stress strain curve. Area under stress strain. So I'm talking about total area, guys. Okay, so total area under stress strain curve is nothing but toughness. Okay, yes, total area under stress strain curve is known as toughness. Is that good? Now, ease of forming is directly proportional to toughness. All right. Is that good? Which is directly proportional to area under is nothing but toughness. This is nothing but energy, right? Toughness is also energy, isn't it? So I'm going to just write it over here. All right, that's energy. Are you getting that? So toughness is nothing but energy here, right? So ease of forming is directly proportional to energy. So Ajit, okay, we will take that question at the end. Okay, I could not understand your question, so please be ready with a better better explanation of what your question is. Okay, ease of forming is directly proportional to toughness because, okay, toughness is nothing but energy. Is it good to you? Hello, do you agree to this? Because we said that ease, that is productivity, right? We already have discussed that productivity is directly proportional to energy, right? So we have already talked about that productivity. Yes, Ajit, that is generally true. Yes, that is generally true. Cold work parts have more strength. Okay, generally that is true because we are not playing with their grains, right? Grains are not, obviously there has to be obviously orientation of grains as well, but yes, generally speaking, the cold work parts have more strength. Okay, now it also depends on the rate of cooling that you're giving. Okay, I hope that you're understanding it. Okay, are you getting? So productivity, can I write it something like this? So productivity is also proportional to toughness because toughness is energy, right? Both are true, है ना? Both of them are true because toughness is nothing but energy. Now please tell me out of this, okay, which one is most, which one, okay, let's say that this is 1, let's say that this is 2, and let's say that this is 3. So which one of these is productivity? Okay, ease of production. So productivity again is maximum for what? Is maximum for what? A option 1, B option number 2, C option number 3. It's already given to you guys. Okay, everything is written over here, right? So D option says none. So which is the correct option here? So first one has low toughness, second one has high toughness because the area is too much here, right? And the third one has low toughness. So which one is the correct option? Productivity is maximum for what? Please tell me. Yes, exactly. Now you're getting that. Yes, Chaitanya. Exactly. Second, Sharmila. Yes, Safu. Second. Yes, the answer is. What about others? Come on, just think about it. We just talked about here, right? So productivity is directly proportional to toughness, isn't it? So which one is the correct option here? 1, 2, 3 or 4? Second, B. Yes, exactly. B is the option here because it has high toughness. Okay, it has high toughness. All right. Now, how do you find that this has low toughness, high toughness? Okay, so let me tell you that. Okay, this is the area of this curve. All right. So let's get rid of all of this. Let's get rid of all of this. Okay, now what is the toughness here? Why it is saying that it has high toughness? Because this area is the maximum. Okay, this area is nothing but toughness. So area equals to are you getting that? No, we have already talked, Anirudh. We have talked about that, right? So energy means that it already has energy, right? So lesser energy will be required to do forming, isn't it? Because it already has energy. That's why it is. Here we have talked about, right? Productivity is directly proportional to energy. Where did we talk about here? More energy than B. Okay, if it has more energy, then what? Then lesser energy is required. Lesser energy is required for forming, right? So that's what we talked about. Lesser energy is required for forming. Yes, area is maximum, Sanjeev, you're right. Okay. Anirudh, am I clear? Okay. So Chaitanya, okay, going by this, no, not like that, okay. Chaitanya, going by this logic over here, okay, because more energy is done in cold forming, all right. So if we have more energy, then lesser energy is required for forming because it already has energy. Similarly here, right, I was giving an example of two people, A and B. They are preparing for GATE, and for A, energy is higher here, right? For B, it's lesser. So which one of these is going to be easy working with GATE? Or which one of them will be motivated for GATE? Obviously A, right? So similarly, going by that concept here, okay, Chaitanya, are you getting that? So going by that concept here, same thing. Area is toughness, and that's maximum. For curve number 2, that's why this 2 should be there, all right? Is that good? Hello, Anirudh? You got it, Chaitanya? Okay, good. Well done, guys, all right? Okay, now Ajit, do you have any question? Ajit, please ask if you have question. So I'm asking to Ajit. Okay, now let me tell you that almost every one of you were brilliant today. All right, now please go back and come back tomorrow again so that we do further dive into it. Okay, Chaitanya. Okay, Chaitanya. Yes. Okay, fine. Are you getting that? Ajit, where are you? So we are going to talk about forming part 2 tomorrow. Okay, same time we are going to talk about. Is that good? Samarth, good. Well done, guys. You were brilliant and I'm proud of all of you. Okay, so 60% gradients in top 100. Okay, fine. Now my name is Rahul KANYAL, and again I'm going to see you tomorrow. All right. Chaitanya, okay. Okay, Chaitanya, okay. Regarding this, if you want to ask, yes, please. ESE questions repeat in case, it can be done, okay. There's no hard and fast rule, okay. Chaitanya, there's no hard and fast rule for this, okay. But yes, our, our focus should be whatever we can do, we must be doing that, okay. That's what it is. Anirudh, okay. Needs more stress is need to be applied on material. More stress for what? Anirudh, Talk in terms of load, right? Don't talk in terms of stress, because stress is internal property, isn't it? It's not in our hands. Okay, previously EEC question repeat. It might be Chaitanya, okay? They might get repeated, okay? Might is the word here. Anything can happen, because there's a limit to the questions that we can make, right? I cannot produce so many new questions every day, isn't it? So yes, it might happen, okay? So Anuruddh, is that good to you? So energy, we have already talked, right? Energy, if there's more energy, then it's easy, right? More energy, then it's easy to form, because it already has energy. Easy to form. Right? Is that good? Just think about it, Anirudh, then come back. Now, if you have not subscribed to our channel, please do it right now, because we will come back with more value-adding services like this. And yes, thank you very much for this, and like this video if you like this. Okay, now I'm not forcing you. All right, if you like this, like it. Otherwise, you can do your honors here, right? So I'm going to see you again tomorrow at the same time, 9 p.m. Till then, keep on thinking, keep on smiling, keep on dreaming. All right, keep on working on your dreams, work hard to give your best, and everything is going to be all fine with you guys. Okay, thank you very much. Thank you. Okay, Ajit, yes. Yes, exactly, yes. So Ajit has asked a question that any tips to improve the rank in GATE. Okay, so what I will say is, Ajit, okay, let's say that we did something like this. All right, we said that, okay, productivity is directly proportional to, energy. Okay, let me tell you that this is never, it's not written in any book. Okay, it's directly proportional to energy. Okay, just make such kind of understanding. Okay, if you understand something, then only you can hit a rank. Otherwise it really becomes difficult. Okay, because everyone's working there, right? Everyone is working so many hours, isn't it? So a success doesn't depend upon number of hours, it depends upon understanding. Like, let's say that, okay, we said that, okay, productivity is directly proportional to energy, right? We understood it, kind of, isn't it? We also went through this example over here, right? So we said that, okay, there are two people, energy is high, so which one of them is more likely to be motivated for GATE? So A is the answer here. So that's the only trick that you need to know, Ajit. Okay, so productivity directly proportional to toughness. This is what understanding, right? This is what understanding. And let me tell you that even if you don't know why is this happening, okay, even if you don't know this why, that is fine, still it is fine. Okay, you should know this, productivity is directly proportional to toughness, and we are measuring productivity here in terms of time. All right, okay, that's what it is. So that is what I can suggest to you, Ajit. Okay, is that good? Now Chaitanya, now what do you want to take in IIT Bombay? That should also be clear to you, right? So IIT B, if you say, so which branch? Obviously you are from mechanical. Okay, you are from mechanical. All right, now obviously if you are from mechanical, I suggest that take design. Okay, if you are from mechanical, take design. Okay, and that has the highest scope. Is that good? Design has the highest scope. Now if you ask me what should be the rank, it should be really very high. Okay, for design it should be really very high. I think that 200 to 300. Okay, minimum 200. All right, so that's what I say. Okay, just focus. Okay, and let me tell you that, okay, don't aim at 200. All right, aim at the first rank. If you aim at first rank, then only you will get a 200 rank. Chaitanya, are you getting that? This is a fact. If you aim at the first rank, then you are going to get a 200 rank. That's why we say that, okay, aim higher, all right? Yes, design engineering, okay? If you are from mechanical, just take design engineering. Otherwise, never take production, okay? This will never give you any job. Production, metallurgy, material, no. Material, there are no jobs out there. Okay, don't take these things. Are you getting that? Yes, aerospace also you can take, okay? Aerospace also you can do. It has a very good placement. IIT has even better placement than IISC Bangalore in terms of aerospace. Did I answer you, Chaitanya? Is it good? Is that good? Yeah, Chaitanya, please go that, okay? I'll be really happy if you can hit a very good rank, okay? Now, again, let me tell you that you should always aim at the first rank over here. Number one, that's all. That's the aim. If you don't aim for this, everything is a waste. Let me tell you that, okay? So that's what it is. All right. Sorry for that. And with that cough, let me say goodbye to, not goodbye, a bye to you. I'm going to see you tomorrow. Till then, just keep on watching it. Again, you know, aerospace also, it'll ask for a rank around 150. Okay, you can check it, all right? I'm just giving you a tentative rank according to my own memory. Chaitanya, all right? Maybe the dynamics have changed here. I'm just trying to tell you, okay, what was the rank? Okay, a friend of mine cleared it. What was the rank and what was his rank, her rank? So this is what I remember. Okay, 150 should do the trick for you. All right, a minimum rank of 150 because everyone fills these. Okay, aerospace, design, these are really very hot branches out there. Okay. All right, Jaswant. Okay, fine. So let me say bye-bye to you. Again, I'm going to see you tomorrow. Till then, keep on washing your hands. Now, can you understand my language? Can you understand my accent? Am I understandable to you? Am I comprehensible to you? Okay, I also use some vocabulary in between. Yes or a no? Or is there any difficulty that you find in my class? You can say it here. Alright, so bye bye, take care guys, take care, keep on smiling. Thank you very much.